I'll probably share this with a couple people, but specifically, I'm gonna go through this. What I'm doing here with this printer shim is for you, because there's a few little pieces in here of information I think that probably help you out later if you decide to do something like this or similar. This case is pretty cool. And check out this little printed air duct. Yep, that's on a stock ender 3S1, I think it is. Got the fan mount in there. That fits right here, right here, and I'll show you in a minute when we go lay the board down. But all right, so back of the machine, got this switch right here. It's an override. This is not working yet, but I got it on my to-do list maybe tonight. That's that ESP32. What is this one? 8266. I don't know what the MOD is. Module, I guess. Anyways, got that. And so its only purpose planned right now is to ground or make it a logic 0 or low on that white wire. Other than that, I got power and ground. I just took a connector and soldered it down. I wasn't paying attention when I grabbed these boards. It's actually bigger than it needs to be, but if you look at the footprint, that's the footprint of an XB, I think. So I believe these modules fit XB sockets. Power ground and a signal wire that goes low. All right, hold on to that thought. Got this loose XT60 right here, but got this nice surface mount, panel mount right there. So we're gonna be replacing that tonight on the to-do list. We're gonna do this. Screws right here. All right, so we got Pi 3B interface right there, board inside. I thought it would have been cooler if there was a way to get to this HDMI. Maybe there is with some kind of adapter. There's a little bit of space in this area right here. We're not using the USB anymore, and I'm glad, because I've been using this thing as an Octoprint with the wire sticking out for a long time. That socket's pretty worn out. Okay, so let's do the powertrain right here. We got 24 volts from the XT60 on that fat red wire straight to this 30 amp relay module. And then on that always hot wire from that XT60, you see that other red wire right there. That's a tap off of that. So it's always hot, of course. That comes back to, let's see if I can get the tools in there. Yep, this guy right here. That's just a buck down converter. So I got 24 in, 5 volts coming out. It's got a potentiometer right there. You can see the screw for. And I stuck down these little heat sinks that color match my stepper drivers. Boom. What? All right. Because they don't come with anything on those little FETs right there. All right. So that one's always on. If you put power to that XT60, this guy's on. There's a sister module further up right there. There's the potentiometer for tuning the voltage, and that other heat sink right there. So 2 of those guys. That one's not on all the time. This one is. So that guy is going to provide always alive power to our relay module and our ESP. That's it. Everything else will be powered down. Alright, so if we activate that when we close the relay via the ESP32 or this bypass switch right there. So that'll give you manual control of the box if home assistant's down or whatever. ESP dies. Alright, so then you got the power out from the normally open contact on that 30 amp. That supplies power to that second DC to DC step down converter. That 5-volt out powers the Raspberry Pi. And taking off of also that same normally opened output is the main power for all of the current going to the printer control board. The only thing we have down below, so I can just lay that control board down, is we have a double 10 amp relay module right there. This thing is packed. This is a really cool design somebody made. Got another module right there. It is tied to GPIO on the Pi. So the 5 volts in is coming in on to the Pi from GPIO pins from that second DC to DC converter there. And then we've got a 3-volt 3 takeoff on there. Let's see, what else did we wire up? I wired up. We got power. Okay, specifically about these relay modules, you have to power the logic if you want them isolated so you don't end up with no backfeed problems. Then you got to move the little jumpers that come on here, or remove the, actually that one got pulled off. I don't even know how that got pulled off. Hang on. Alright, back in business. But you have to move a jumper to select whether the coil part for the relay is energized by quote-unquote VCC, which is also powering the opto isolators, which is supposed to isolate your circuit. So even though you get an opto isolated relay control board, the coil from that is not actually isolated by default unless you take the jumpers off. When you take the jumpers off, then you either, depending on the way the module is made, you can choose to move the jumper over left or right and make that change, and then get your coil power supply from a different screw terminal that they have on there. Or you can just remove the jumpers and then put in your supply, which is what I've done right here. There was jumpers here. Remove them and then put the power for the coil part of the relay supplied from the 24 volts, because this has a 24 volt coil inside. I picked that because when this is on, you're passing quite a bit current through here, and this is just going to keep the current down. This allows me to power the coil without drawing from either of those two DC to DC converters, which is really important because one's not doing much work and the other one's got a lot going on because of the Pi, right? So we didn't really need to be powering our relay coils and such, especially a big one is going to have more electromechanical clamp and current for the coil from either of those converters. That didn't make sense to me. So this is native voltage from our main supply source, right, coming from the XT60. So that's pumped in there. Now on these screw terminals, we've got our input and our ground and our power. This is not the 24 volts. This is getting power from the always on DC to DC converter back there. So that even if we are sampling some power for the opto isolator, it's still not influenced on the one that's dedicated to the Pi. Same thing for these two guys. They work the same. Remove those coils, but these, if you look at them, are 5 volt coils. So they don't get powered natively like the big one does. They don't draw as much current when activated as the big one does. And let's see, do I have those guys powered? I actually do have that powered off of the Pi. So, not off the Pi, but off of that other DC to DC converter. I think I should actually probably change it. I think I should probably move it to the always alive one. That was silly. Glad we had this talk. So I'm probably going to change that over. It's just a matter of moving those wires from one DC to DC converter, right? Alright, let's see. I'll set this thing down for a second and lay the wires and board down right. Mostly right. Into relative placement. Probably should put one screw in. Okay. Check it out. Alright, kind of older board. Definitely nothing that new. I'd say it's kind of getting old now. And I think I got this board out of the bargain bin, like Amazon return. I think it was $6. So, okay. It works. So I'm down with that. Got your limit switch ports right here. Where my tweezers at? Got them limit switches right here. Your temperature inputs for bed, hot N1, hot N2 if you got a dual are right here, but I've only got this one used. Notice that one is for the bed. We got a whole bunch of jumper options right all through there, man. It's like it's a lot. You got 3 cable, well, I had 3, but 2 cables right here. There's 2 gray ribbons go to the display, and that black ribbon normally would go to the board right here on this header, which is a serial port header. But now I have that routed to the Pi's GPIO serial connection down below. So it should be connected there. You would if this was like a Marlin setup or a typical like plug and play kind of deal, not a non-clipper deal. Alright, so we got some upgraded, what were these? TCM 2226s, I think. Similar to 2208s, but more current, bigger, better. Added these little heat sinks right here. They're actually Big Tree Tech driver boards below. So Big Tree Tech board here. SKR version 1.3, right? Boop. And then, so let's see what we have. We got 1, 2, 3, 4, 5 sockets on board. Notice this one is different. What we got? We got a Max 31865 version 2.0.1. Big Tree Tech, right? That guy right there is a digital, analog signal amplifier and a digital converter. So all these little sockets right here are driven by a couple of different ways depending on which drivers you choose. Something fell over. You got just pins that are fired off by the MCU right here. Those are step pins, direction pins, and enable pins. Simple. Oh, and like it's well, yeah, I guess it's digital because it's high and low signals, but simple. Or you can command these drivers what to do a couple different ways. Serial or SPI bus. So you can choose that with all these jumpers and stuff. These don't let me tell you wrong. What does these jumpers say? I'm pretty sure that jumpers are connected for UART, so I'm thinking those are serial. In fact, that's probably not as fast as SPI, right? Alright, so we have 4 of those drivers there, and then we've got this, which is the temperature sensor plugged into the same port that a stepper motor would be, using this little I don't know, let's call it footprint or whatever, the way they adopted the use of that socket, because you could do this standalone wired into the board other ways and then just have your temperature probe attached to it. But in this case, it's like plug and play on this board, so we took advantage of that and used this socket. Not only 2 wires are actually used for the probe. That temperature probe, right there, that's the PT100 high temperature probe. It'll read up to 500 degrees Celsius, which is 1,000 degrees, 980 degrees Fahrenheit. This is the Big Tree Tech, what is it? I don't know how they say it, Beak. H2. There's a newer one, H2 like VS or something. It's supposed to be better than this one. This one was a little cheaper. And I had to come up with a different gantry. I got the small wheels going. I don't think that's better. I just wanted to shed weight because that thing is heavy. It's pretty compact. I mean, it's long. I mean, you know, it's wide, But otherwise, it's 30 millimeters square, and they did a really good job of getting a really nice direct drive system right there. Like, this thing is like a filament load. When it's hot, right, you can move it. This thing is just like a wheel that you can roll with your finger. It's got the planetary drive 7-to-1 gear reduction deal, and I'm really liking this extruder hot end. So I'm thinking I might go serious on this guy, right? Let's see what else we got going on. Okay, yeah, display. All right, man, I don't know. Here's the real deal. I think I messed up. This is the big Tree Tech TFT35 E3 version, which is for Ender 3. It's supposed to be more plug and play with Ender style setups, which is kind of hit or miss anyways. The reason why I say that is Ender runs Marlin firmware, and that's where I run into some issues. So that display, it's got a really nice interface. It looks cool when it's on. It's got color, it's got touch. But all of the commands and information in exchange for the display goes down through that serial cable, the black one. I don't even know why we need all those gray ones, to be honest. I might just have to unplug them and see what happens even. But it's supposed to be because this thing is supposed to be in compatibility mode, where you like push and hold the button for 3 seconds. It goes back to like an Ender display. I think it's supposed to do the Ender thing over those cables right there. But it don't matter because we don't even have Marlin firmware like Ender does. All right, so I think it sums it up on the hardware. Oh, my BL Touch broke. This does support it, but I don't know. It was working when I took it off. It's not now. I used the meter, and pretty much it's a done deal. Power's on. It does a little tick thing, but it doesn't send a signal out, and that's verified from it not connected to anything else. So, gonna get another one. Let's see what else it says. That's it on the hardware. All right, check back with a video on the software.